Good morning everyone. My name is Luke Sussex and I am a Spatial Advisor at Abley, and today I am presenting a project we worked on with Transpower to combine their own Access Track dataset with Arcgis StreetMap Premium. For those who don't know, StreetMap Premium is a road network that can be used for turn-by-turn navigation as well as network analysis. An access track is a track that deviates from the public road network, allowing Transpower workers to access assets like pylons. These may be farm tracks or other informal roads. Transpower came to us with a dataset of tracks in various point locations such as power poles, bridges, gates, and a desire to be able to navigate to these different assets. This presentation will show the process we developed to integrate these features with StreetMap Premium, as well as some of the challenges faced when working with data in different formats. The end result was a mobile map package for use in ArcGIS Navigator, capable of providing turn-by-turn directions to specific assets such as power poles. While it is just me presenting today, I want to give credit to my colleagues Robert Pointer and Andy Bartle, as well as Mark Pesey from Transpower, for their help at different stages throughout this project. So phase 1 involved a road network comparison. This was to determine the most suitable public road network for integration with custom data. Networks we considered included TomTom Multinet R, HERE's road network, a road network that we here at Abley have developed from OpenStreetMap data, as well as Arcgis StreetMap Premium. We compared factors such as completeness, accuracy, and price. The most important factor, however, was if we could add our own tracks onto the network. To cut a long story short, we recommended the use of the custom roads version of Arcgis StreetMap Premium, which is specifically designed for custom third-party data such as access tracks to be added onto the network. This network would also work well with the mobile routing application Arcgis Navigator. Other mobile applications were considered, such as TomTom Go Mobile and of course Google Maps, but the downside to these two was that you cannot add your own custom road data. In phase 2, we assessed the input data to understand how we could merge the StreetMap Premium network with the Transpower Access tracks. We first used FME and a little bit of Abley magic to identify these tracks that run parallel to the StreetMap Premium roads, as these are considered duplicates. It is important to remove these duplicate tracks to keep the network clean. There were two main difficulties we encountered when identifying duplicate tracks. The first were cases where a track runs parallel to a road but on the other side of a solid object such as a fence or a hedge, so it's not actually a duplicate and therefore should not be deleted. The second issue with identifying duplicate parallel tracks related to the accuracy of some StreetMap Premium roads, especially in rural areas. Access tracks were often more complex than StreetMap Premium roads, resulting in the track being classified as not parallel when in actual fact it is. The FME process flagged these parallel tracks, which were then reviewed by Transpower. The second part of phase 2 was to assess track connectivity with the road network. Either a track intersects a StreetMap Premium road and a vertex is created at that point, or the track connects to the endpoint of a StreetMap Premium road. It was important to keep in mind that StreetMap Premium uses endpoint connectivity rules when joining tracks onto this network, as this meant that override points were needed. Using FME and some more Abley magic, we identified how many tracks fall short of intersecting a StreetMap Premium road and how many intersect and overshoot the road. Each type of track was classified and reviewed. The results of this first phase of analysis were positive. There were a low number of tracks that require a manual review, which was done by Transpower. This saved them time as most of the tracks did not need reviewing. The last step in the analysis phase was to prepare the track data for joining onto the StreetMap Premium network. For tracks that were less than 1 metre from the road, these were extended using FME to intersect with the main network. This was important to tidy up any digitization errors where lines had not snapped together correctly. Tracks with start points that were greater than 1 metre from the network were manually assessed and edited to connect them to the network. as it is not always a direct straight line connection from the track to the road network. This was only about 2% of the whole track dataset, so it didn't take too long. There were several cases where StreetMap Premium roads cut through farms and through areas that did not seem correct, such as here next to some animals. Others just went to random places. Even the shape of this road is a question mark. There are also roads which appear to run down drainage channels, so I don't think that's quite right. Another example of the so-called paper roads can be seen with relation to parcel data. It seems the curved section of road has been inferred from the road land parcel. When looking at the base map, it is clear that the road stops at that intersection at the top with the track and does not curve around to the right. There were also cases where StreetMap Premium is up to date, for example this new section of motorway, but the base map imagery is out of date. This made it hard when manually connecting tracks to roads because you could never be sure if it was the base map imagery or StreetMap Premium geometry that is the source of truth. Phase 3 involved creating and testing the routable network. The steps to do this are nicely laid out in the Arcgis Pro Tasks that come with the StreetMap Premium Custom Roads version. Several of these tasks we had already implemented using FME prior, as this had given us a better understanding of the data and how it will merge with StreetMap Premium. However, a few of the tools under Task 5 in particular were helpful in resolving any minor connectivity issues around snapping tolerances. Other tasks, such as the setup turns task, were skipped as there was no need to model turns within access tracks. When building the network dataset, I made sure to set the extent to just our area of interest, as this meant that when we rebuilt the network, it only did it for the Waikato area and not all of Asia Pacific. The Verify Network Connectivity task essentially aims to show you where islands exist in your network. The concept of islands in a network is simple to understand but complex to test for. So track A on the left here is considered an island because it is not connected to the main network, StreetMap Premium Road and other tracks. It's easy enough to visually identify this, but only because the gap is quite large. What if it looked like track B, which appears connected, but when you zoom in, you see that it is just off by a little over a meter? If we were to zoom in all the way for each of the tracks and verify that they had been connected correctly, this would be a very time-consuming task. So even though the previous tools provided and the FME workbench we developed all aim to fix any connectivity issues, it is always useful to check that there are no remaining islands using network analysis, as this will save time and is less error-prone. The tool provided with StreetMap Premium was not efficient on the scale that we were working at, so I used a separate Python script that I had developed previously, which simply reads in a network dataset and identifies all of the islanded segments, like I've just mentioned. Again, a little bit of Abley magic was used to do this, and the Python script just identifies the sections that it identifies as islands, and these get flagged for manual review. Of the nearly 8,000 tracks that we were integrating, there were about 300 that were identified as islands, and about 90% of these were due to incorrect Z levels, which had to be manually corrected. The Z level tool included with StreetMap Premium did not fix these issues. It fixed some, but didn't fix others. Once we had created the network, containing all the access tracks, we needed a way to search for custom assets. To do this, I created two custom locators from the different asset data we had. This allows Transpower staff to search for specific pylons or gates and stuff by their unique IDs. Transpower were then able to take the updated StreetMap Premium network, publish a mobile map package for use in the Arcgis Navigator app. This allows for easy turn-by-turn navigation by Transpower teams in the field to follow routes to chosen assets. This saves time and prevents workers getting lost when responding to issues. Going forward, It could be possible to incorporate alerts for different routes to let you know the gates you need keys for, as well as the different load limits of the bridges you might end up crossing. The end result is a significant amount of time saved from manually joining tracks onto the network, as well as a repeatable process that can be used across the country to update and maintain the network. The Arcgis StreetMap Premium Custom Roads Network Dataset performed as expected, but it is important to be aware of its downsides and how the data you want to add to it will work with it. This is where the analysis we did can help you with your navigation needs. Thank you all for listening, and I'm happy to answer any questions you might have.